Hey all you cool cats and kittens. Today's video I'm going to go over how to solve quadratics. So there's kind of like three different good methods in my opinion to solving quadratics. And it really depends, which method is best depends on what kind of quadratic you have. So in my opinion, the easiest kind is when you have a variable squared but no linear term. And what I mean by linear term would be like, okay, if this had like p squared plus p equals 68. If there's a term with a variable that doesn't have a power of 2, like a power of 1, okay, that's a linear term. And those are a little bit more challenging. But when there's only one variable and it's just to the power of 2, it's a lot easier to solve. So basically what you want to do is you want to isolate the variable that's being squared, okay? In this case, for problem 1, it's already isolated, right? And you can think, well, how do we do a square? Well, you square root. Now, if you look, I just added in a square root symbol. So when you yourself add in a square root symbol, you have to add in plus minus. So then I get x equals plus minus root 47. So then at this point, you want to see if you can break root 47 down. So you would go back to that radical, back to thinking of how you simplify radicals, and you would see if any perfect squares go into 47. Spoiler alert, none do. So your answer here would just be this. Let's say you didn't know that. You would have to go ahead and do like 47 divided by 36, 47 divided by 25, 47 divided by 16, 47 divided by 9, and 47 divided by 4. None of those work, so we're stuck with just plus minus root 47. All right, now let's go ahead and check out one where you got to do a little bit more work. So let's check out this one. We need to get this guy by himself. You need to get the variable that's being squared, all by himself. So to do this, I'm going to go ahead and subtract 9 from both sides. So I end up with 7n squared equals 632 minus 9, which gives me 623. So then I'm going to go ahead and divide by 7 on both sides to get my x squared by itself. And I get 89. All right. So then we go ahead and we see if there's any perfect squares that go into 89. Right, we would do plus minus. We get n is plus minus root 89. So then we could go ahead and check our numbers out. We'd want to check 81, 49, 36, 25, 16, 9, and 4. Again, spoiler alert. None of these go into there. And what I mean by none of these go into there is I mean that none of those are factors. So like, for example, if I do 89 divided by 49, just kidding. There we go. It doesn't work out, right? I get a gross decimal. Same with 36. 89 divided by 36 doesn't simplify, so we're stuck. So this would be your answer here. All right. But of course, if it was something that you could simplify and simplify the radical for, you'd want to go ahead and simplify that. All right. So again, for problems like these, what you want to do is isolate the variable that's being squared, okay? Now, we're going to solve by factoring. So these ones are different in the sense that they have a linear term, right? They have a second variable in there that's not squared, okay? So what you want to do here is solve. First, you're going to check to see if you can solve by factoring. Factoring is always the easiest way to solve a quadratic with a linear term if the problem's factorable. And I know that we've seen that sometimes you can't factor quadratics, right? They'll say that they're prime or you just can't factor them. And in that case, you're going to have to go ahead and use quadratic formula, which we're going to do later. But these you should be able to do. So we'll go ahead and take a look at 15. So we want to factor this. We got to figure out what multiplies to give us a negative 24 and adds to give us a negative 2. So this is where you're going to want to write out all of the factors of negative 24. Well, we'd have negative 1 and negative 20, or negative 1 and positive 24, my bad. And then we would have 1 and negative 24. That doesn't work. So then I could go ahead and do negative 2 and 12, or I could do 2 and negative 12. Also doesn't work. So I could do negative 3 and 8, 3 and negative 8. Doesn't work because I'm looking for something that adds to negative 2. Then I can go ahead and try negative 4 and 6. Getting closer, we do 4 and negative 6. these guys add to give me the -2 that I'm looking for. So that's going to be my jackpot there. So I'm going to go ahead and do n plus 4 and n minus 6. And what I can do now is I'm going to take these factors and set them equal to 0. Now, it's important that you understand what you're doing here. You're taking this factor and setting it equal to 0. So you do n plus 4 equals 0 and n minus 6 equals 0. You would subtract 4 from both sides. You get n equals -4. You add 6 to both sides, and you get that n is 6. So you get 2 answers there. All right. Now, if you notice, this was already in what we call standard form, and it was set equal to 0. Okay. Now, sometimes you're going to get quadratics where they're not set equal to 0 yet, and you got to do a little bit of work. So let's go ahead. We'll try number 19. All right. So this one is not set equal to 0 yet. I got terms on both sides. Now, what I recommend doing is you want this guy with the square to be positive. It makes things a lot easier to factor. Can you factor with a -a value? Yes, but it's kind of gross. So what I would recommend doing, since this x squared is already positive, we're going to move this stuff over to get it set equal to 0. So we're going to add 8x and add 4. All right, so I end up with x squared plus 8x plus 11 plus 4, and that's now going to be set equal to 0. Okay, then we can combine some like terms. We get x squared equals 8x plus 15 equals 0. So, of course, we're going to go ahead and try and factor this. So we got to figure out what multiplies to give me a 15, adds to give me an 8. So we've got 1 and 15, or we could do -1 and -15. Not going to work for me. And then I could do 3 and 5. This guy works. So we're going to do x plus 3 and x plus 5. And then we're going to go ahead and set these equal to 0. We get x equals -3 and x equals -5. All right. So again, you need to make sure that you get everything on the same side. Okay. And again, try and keep that squared term positive. It makes things a heck of a lot easier. All right. So now we're going to go ahead and try number 25. Now you're going to find that 25 is a little bit tougher. So we'll go ahead. As we can see, it's a quadratic. We got these squared terms, and then we also have a linear term. So that tells us that we need to get everything on the same side and set it equal to 0. So I'm looking, and I want to make sure I keep this square term positive to make my life easier. So what I'm going to do first is move this 8b squared over. All right, and then I'm going to go ahead and subtract 7b. All right, so these guys go away, and I get 0 over here. And then I get 7b squared, and then -18b minus 9, okay? So now you might be looking at this and you're like, well, Miss Slater, I don't know how to factor this. And some of you may know how to factor this, and some of you may not know how to factor this, and that's okay. If you know how to factor it, go for it. It's that thing where you have to multiply the 7 and the 9, and then, you know, factor out at the end the greatest common factor. If you know how to do that, great, go ahead and do it. But I'm guessing that a lot of you guys struggle with that. So when you end up with something like this that you can't factor, what you're going to do is you're going to go ahead and use the quadratic formula. All right, so the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully that looks kind of familiar. So if we're looking at this quadratic here, we need to be able to identify a, b, and c. So a is the guy that is attached to the squared term, b is the coefficient attached to the linear term, and c is your constant at the end. So here our a term is 7, our b term is -18, and our c term is -9. I apologize for my handwriting. I left my Apple Pencil at home today. So then we're going to go ahead and plug these into the quadratic formula. Now with -b, what I always say is you do opposite of b, right? Because it's -b, so you switch the sign. So if I have a -18, it's going to become a +18. And then I'm going to go ahead and do plus minus the square root. And then I've got b squared. So I'm just going to go ahead, I'll get out my calculator to show y'all. So I'm going to do 18 squared, which gives me 324. All right, and then it's minus 4ac. So we're going to do 4 times 7 times negative 9. And then that's all over 2 times a. So 2 times 7, which is going to give us 14. So what I recommend at this point is that you take what's inside of the radical and plug it into your calculator. So we're going to go ahead and do that. So we've got 324 minus, open parentheses, 4 times 7 times negative 9. Close parentheses, and we get 576. All right. 576. All right. So we end up with 18. Why did it not stop writing? There we go. 18 plus or minus the square root of 576 all over 14. So at this point, we need to simplify the radical. Now, sometimes you're not going to be able to totally simplify it, as in there's still going to be a radical left there. But in this case, we can actually take the square root of 576. That's equal to 24. So we end up with 18 plus or minus 24 all over 14. So we can actually get some numbers here. All right, we're going to do 18 plus 24 all over 14. And then 18 minus 24 all over 14. All right, so let's go ahead and do that. And make sure when you plug these in, you use, I would put parentheses on the top to make sure that you don't mess up the work of that. So we're going to do 18 plus 24 divided by 14. It gives me a 3. And then I'm going to go ahead and do 18 minus 24 divided by 14. And let's see if they give me, it's negative 3/7. All right. So we've got it here. Very nice. So that is how you could do it when you don't know how to factor it. Okay. Use quadratic formula. Now, there are going to be some instances where you have to use quadratic formula, where you just straight up can't factor it, which is fine. So let's go ahead. Let's see, what would be one? I just want to see one that we know isn't going to factor nicely. Let's go and do number 29. I feel like that's a good one to do. All right. So for 29, this is one of the ones where it's telling us to use the quadratic formula. So that's what we're going to do. So again, we have a quadratic here because we have a squared term. We also have a linear term. So we want to get everything on the same side. So I'm going to go ahead and add 8m to both sides. So I get 7m squared plus 8m minus 24 equals 0. All right. Now again, we've got that leading coefficient here. So this one we actually can't factor at all. You could try, and basically when you get to the point where you're like, I can't factor this, you know you have to go to quadratic formula. So we're going to go ahead, identify our A, B, and C terms. So our A term is 7 again, our B term is 8, and our C term is negative 24. This is kind of similar to what we had before. So then we're going to go ahead and use the quadratic formula. I'm going to write it out again just so we have it. So it's B, negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, so we're going to go ahead and plug those values in. So we do opposite of B. So in this case, it's just going to be negative 8 plus or minus the square root. And then B squared is going to be 64 minus, and then we've got 4. Yeah, we're running out of space here. Obviously struggling without my pen today. All right, so 4 times A, which is 7, times C, which is negative 24. My handwriting's so bad. There we go. And then that's all over 2A, which is going to be 2 times 7, which is 14. All right. So again, I'm going to recommend you go and plug what's inside of this radical into your calculator. So we get 64 minus, and then we've got open parentheses, 4 times 7 times negative 24. All right, we get 736. So you've got negative 8 plus or minus the square root of 736 all over 14. Oh my goodness. So we have to break down 736. So basically what we're going to want to do is we're going to want to try to figure out some perfect squares that go into there. All right. So if we have 736, we can start with, I don't know, let's start maybe with 100. Let's see if, all right, so 100 doesn't work. 736 divided by 81 doesn't work. 736 divided by 64 doesn't work. 736 divided by 49 doesn't work. 736 divided by 36 does not work. 736, oops, delete, divided by 25 doesn't work. 736 divided by 16. That one does work, all right? So we can go ahead and break this down. We're going to do -8. Or actually, I guess let's simplify the radical specifically. So we know 736 is going to be equal to 16 times 46, which becomes 446, right? So what we're going to do is we're going to do -8 plus or minus 4 root 46 all over 14. So we are almost there. Now we just need to simplify our answer here. So basically what you got to do is you have to figure out what can I pull out of, or I guess you ask yourself, can I pull anything out of 8 and 4 that's going to cancel with 14? And looking at that, I could definitely take a 2 out. So I'm going to take a 2 out, and I get -4 plus or minus 2 root 46 all over 14. These guys cancel, and this becomes a 7. So my final answer is going to be -4 plus or minus, 2 square root of 46 all over 7. And that is your answer. So hopefully this is kind of ringing a bell. Hopefully this is a little bit familiar. And we'll go ahead and we'll work on this in class.